All right, next up in our volume unit here is the volume of a cylinder. Now these cylinders are what we call right cylinders. They stand up straight, so this angle right here is 90 degrees. To calculate the volume of the cylinder, all you want to do is really just calculate the area of one of the bases, which is of course a circle, and then just multiply that times height. Pi r squared times h. Number one, volume is pi r squared times h, pi r squared times 12. So you go to your calculator, 36 times 12 pi is 1357.168 cubic kilometers. And if we're thinking about what that actually means, this is of course a massive cylinder, it's not realistic, but if you were to fill this thing up with, let's say water, right, it'd be how much water goes in the cylinder. In this case it's a gigantic cylinder, but hopefully you get the idea. Alright, we're talking how much stuff goes inside. And for cylinders it's things like soda or soup or something like that. Number two, we have, let's see, volume is pi r squared times h. The radius is, the radius is half of 18. Half of 18 would be our radius, so 9. So be careful when they give you diameter, you can't use that as your radius. That's 9 times our height is 5. So it's, let's see, 9 squared is 81 times 5 times pi is 1272.345. And that is a cubic measurement there. Number 3, volume pi r squared times h. The reason I gave this example is because it's kind of sitting up on its side, so we need to make sure that this is our height and our radius, put it in green, our radius is from here to here, so that would be 4. So just be careful that you're not accidentally using the height as your radius or vice versa. And let's see, that's 16 times 2 is 32 times pi is 100.531 cubic meters. There we go. Number 4. So far so good. Here's a little bit more of a challenge. This tank of water is filled within 30 inches of capacity. How much water is in it? Alright, so that means that within 30 inches of capacity, that right here, you can see there's a little dotted line. That is kind of like the empty space. Within 30 inches of capacity. And the empty space is 30 inches. Well, if the whole thing from top to bottom is 48 feet, be careful with your units there, it's feet. 30 inches in feet is, let's see, there are 12 inches in 1 foot. 24 inches and 2 feet, so 30 inches would be 2.5 feet. So the distance here, the empty distance here is, let's see, 2.5 feet. So what I'm going to do is I'm going to take this over here and draw another little picture for myself, because I don't want to go up all the way to 48 feet, but I only want to go up to where the water is. The water is right in here. And that doesn't go up to 48 feet because it's not full. It's pretty close to full. And the actual height of the water is 48 minus 2.5. So that's how high the water goes up. And the diameter is 25 feet. We don't want diameter, we want radius. So the radius is half of that. Alright, and then all you would do is calculate that volume. So you can go volume is pi r squared times h, pi times 12.5 squared times 45.5. And that will give you your answer. That comes out to be, let's see, 22,000, I'll put it over here, 22,334.76 cubic feet. And that's how much water would be in this tank. Last one. So Farmer Brown is buying a new water tank for his farm because he needs more water for his crops. His current tank is a right circular cylinder that is 5 meters high and 6 meters across. At the store, he was given a choice of 2 tanks that he could purchase. The first one has twice the height of the current tank but keeps the same width. The second one has the same height but twice the width. Okay, so let's draw a picture of his current one. His current tank is 6 meters across and 5 meters high. So it looks something like this. 5 and 6. Okay. Option one is a tank that has twice the height and the same width. So if I draw this thing, I'm going to draw a tank that's much taller but exactly the same width. So it's twice as tall but exactly the same width. So let me scroll down here a little bit. That's option one. Option two I'll put over here. Has, let's see, twice the width, so it's twice as wide, but it keeps exactly the same height. So I'll draw it down here on this level. And the question is, if both of them cost the same exact amount of money, if both of the new options, this is 12, which one should he buy? Alright, so that's the question here. This is really a question of value, value, money over volume, essentially. So how much money are you spending and how much volume are you getting in return for that money? So what I'm going to do here is just compare volumes. The money doesn't matter because it stays the same. So I'm just going to go pi r squared times height. That comes out to be, let's see, the radius is not 6, but it's 3. 3 squared times 10. So that comes out to be 282.74. And that would be cubic feet. And the volume over here for the second option is, let's see, pi r squared. R is 6 in this case, and height stays the same. So it's, let's see, pi times 36 times 5 is 565.487 cubic feet. So what that means, he's basically getting himself, for the same exact price, he's getting himself a whole lot more volume for that same price. So, if you are Farmer Brown, you definitely want to do your math and go with option number 2. Same price, a ton more volume, so that's kind of a no-brainer.